The James Webb Space Telescope has as of late sent Earth a massive exhortation, and it's moving closer. This advice comes from the exoplanet Proxima. With each new picture sent back, extra requests arise, leaving experts terrified. Each portrayal from this distant planet makes us wonder more about the mysteries of the universe. Developing requests are emerging about a potential threatening planet near Earth. Might there be a connecting outsider planet with disagreeable expectations? Might Proxima B at some point represent a danger to our actual presence? The subject of outsider life has spellbound humankind for quite a while, yet with current innovation similar to the James Webb Space Telescope, it has turned into an inquiry we can investigate more completely than any other time in recent memory. However, the universe isn't making it simple to track down replies. We keep on utilizing our best instruments. Similar to the James Webb Telescope, we get looks at far-off planets and system, expecting to find information insinuate life past Earth. We should be reasonable. However, every new picture and snippet of data for the most part reminds us how little we truly know. While these disclosures could be groundbreaking, they likewise feature the immensity and intricacy of the universe, leaving us with additional inquiries than addresses. Understanding a far-off planet like Proxima B could rethink our spot in the universe. For researchers in cosmology, this is energizing, yet for the overall population it frequently feels like simply one more piece of room news, far off conceptual, and in some cases overpowering. These disclosures bring up additional issues than they reply, driving numerous to consider how this influences life on the planet. Might Proxima B at any point genuinely hold on to life, or even keen life that might one day at any point represent a danger to us? Notwithstanding the huge force of the James Webb Space Telescope, it can indeed show us a limited amount. A lot of course, we've taken in few amazing things, similar to how we presently have dazzling new pictures of Proxima B, and we realize that the universe is far greater than we at any point envisioned. However, what comes straight away, the viable ramifications of these disclosures can feel as tremendous as the actual universe. Proxima B found in 2013 because of its gravitational communication with its star was a significant logical forward leap. Finding this exoplanet resembled finding another enormous neighbor. Proxima B is somewhat bigger than Earth, and it circles its star at regular intervals, making it a fascinating subject for additional investigation. According to a logical viewpoint, the possibility of a different universe so near our own is thrilling. However, for a great many people it's difficult to interface with a spot that is 25 light-years away. To place that into point of view, even the quickest space apparatus people have made would require millennia to arrive at it. Envision what remaining on Proxima B may be like. Its star Proxima Centauri would show up as a major faint red light overhead, a lot cooler and dimmer than our sun. Proxima B surveys so rapidly that a year there endures a little more than 7 days. One side of the planet generally faces the star, meaning it is secured in never-ending daylight, while the opposite side is canvassed in unending evening. It appears as though something out of a sci-fi novel. However, the truth would be undeniably more ruthless. On the splendid side of Proxima B, any water would probably bubble into steam because of consistent openness to warm, while on the clouded side the water would freeze into strong ice. The planet star Proxima Centauri is likewise not a quiet and consistent neighbor by our sun. It tosses out risky flares and extraordinary radiation, making the outer layer of Proxima B a dangerous spot for life. As far as we might be concerned, this isn't the sort of neighborhood where people would need to settle down. Interest in finding life past Earth hit a top in late 2020 when researchers recognized an uncommon sign coming from the Alpha Centauri framework where Proxima Centauri is found. This sign had a special recurrence 982.551 megahertz, which grabbed everybody's eye. Such a sign could in principle show trend setting innovation, yet it is too early to make any ends, all the more as of late the James Webb Space Telescope created significantly greater fervor by recommending that Proxima B could have water fume in its air. Water, as we probably are aware, is a critical element forever, and its presence could be a distinct advantage to more readily comprehend how much water is available on Proxima B. Researchers are utilizing progressed strategies like spectroscopy. This strategy permits them to identify the gases encompassing the planet, behaving like a cutting-edge criminal. Investigator device. By investigating the planet's light range, researchers can distinguish explicit gases like oxygen, methane and carbon dioxide, which are all fundamental forever barometrical. Displaying is another key methodology. By utilizing automatic experiences of Proxima B's climate, researchers can make reasonable deductions about its circumstances. These models fill a comparable need to how researchers use dinosaur issues that remains to be worked out. What dinosaurs could have resembled. Notwithstanding, the more we find out about Proxima B's climate, the more we are helped to remember the fantastic variety of life frames that exist here on the planet. Extremophiles, for instance, are little creatures that can get by in outrageous circumstances, exceptionally underground aquifers, acidic lakes, and the freezing cold of Antarctica. These versatile animals demonstrate the way that life can flourish under conditions once thought inconceivable. Might life on Proxima B at some point be comparably versatile? The quest for life on Proxima B presents colossal difficulties as far as space travel, as well as in demonstrating that life can exist in such an unfriendly climate. The planet is assaulted by serious space radiation, and its environment probably won't offer a lot of security. Also, the distances included are tremendous, to the point that new kinds of impetus frameworks are important to make space travel to Proxima B plausible. Ideas like sun-oriented sails, particle drives, and surprisingly more hypothetical thoughts like twist drives offer energizing opportunities for future investigation. Notwithstanding, these advancements are still in their outset and require broad exploration before they can be utilized in genuine missions. While dreaming about future space travel is exciting, we want to stay sensible. Finding life on Proxima B is loaded up with innovative and logical difficulties. Simply by propelling our innovation and growing comprehension, we might interpret the universe. Could we at any point desire to open the maximum capacity of far-off universes like Proxima B? This pursuit isn't just about fulfilling interest, it's tied in with pushing the limits of human accomplishment. Might we one day go to Proxima B or even connect with life there as we consider the long excursion to Proxima Centauri? Finding outsiders no longer feels restricted to the domain of sci-fi, but instead appears to be a genuinely unmistakable chance. This thrilling movement from a far-off dream to a logical undertaking has drawn in serious consideration from state-of-the-art associations like Advancement Drives. These gatherings are devoting tremendous assets to changing what might normally be an unthinkably lengthy excursion, one that could require millennia, utilizing the present innovation into a mission feasible inside many years. The objective of arriving at one more star framework inside a human lifetime has ignited development and confidence in established researchers. Notwithstanding, these excellent aspirations are immediately tempered by the unmistakable real factors of our ongoing innovative cutoff points. In spite of exceptional advances in space investigation, heading out to Proxima Centauri, even at 4.2 light years away, still presents overwhelming difficulties. Current impetus frameworks are basically not quick or proficient enough to make such an excursion conceivable in any sensible time span. Advancement Starshot, perhaps of the most aggressive venture, imagines utilizing strong laser-driven sails to impel small space apparatus to speeds up to 20% of the speed of light. While this idea shows guarantee, it's still in the exploratory stage and requires beating various mechanical and calculated obstacles, for example limiting harm from space garbage and guaranteeing exact significant distance correspondence. While the fantasy about arriving at Proxima Centauri and possibly finding outsider life is nearer to reality than any time in recent memory, it remains grounded by the limitations of present-day innovation. Speeding up a space apparatus to approach the speed of light with the present devices feels remarkably difficult, like attempting to tackle a troublesome riddle in obscurity. Indeed, even striking tasks like star shot, which mean to push a space apparatus toward Alpha Centauri utilizing lasers, face critical useful difficulties. The world's air makes aggravations for the lasers, making it challenging for space investigation devices to work with the accuracy required. One proposed arrangement is the utilization of versatile optics, more modest lasers on satellites that consistently screen and adapt to environmental aggravations. This framework would help strong ground put together lasers remain on track with respect to rocket as they travel through space. Nonetheless, the laser drive strategy requests a huge measure of energy identical to the complete energy consumed by the whole us, and it would just work for a concise period. Envision setting up 100 million lasers over a tremendous region just to push a little rocket just 33 feet wide to 20% of the speed of light. At this speed, the space apparatus would in any case require 22 years to arrive at the Alpha Centauri framework, a time span longer than many individuals' lifetimes. However, the test of arriving at Alpha Centauri isn't just about defeating specialized deterrents. There are regular hindrances to the gravity of the sun, the presence of room trash, and the sheer immeasurability of the distance implied. All posture huge dangers in any event. Speaking with a shuttle in transit to Proxima B would want to send messages through time. It would require around 4 years for a sign to arrive at it from Earth. In spite of these overwhelming difficulties, the longing to investigate other star frameworks keeps on developing. It's driven by